Okay. So there's an easy way to do the derivative. But first we have to do it the hard way. You would be expected to do it once at least on the exam the long way. Okay. But first, let's go ahead and talk about what is a derivative as a function. And then we'll go ahead. Go from there. All right. Let's pick a function from the homework. Maybe this one's cool. 4x cubed plus 2x squared. 4x cubed plus 2x squared. Okay, so the concept, I'm hoping you saw the theory in the notes or in the book or in the videos. But in a nutshell, you basically picture points right next to, actually, I'm gonna need a, yeah. So if I choose this point right here and draw a line tangent to that point, if I pick another random point over here and draw a line tangent to that point, right over here, we're going down, right? At this point, we are horizontal. So notice that these peaks and valleys, right? They have they go from increasing to decreasing. So these are considered to be maximums and or local maximums and minimums, what we'll talk about later. But we at those special points, you go from increasing to decreasing and then back to, as you can see, increasing. So what the derivative does is you plug in any of these points into the derivative, and it'll tell you the slope that is tangent to those points. So right next to the random point, what's the slope of a line right next to it? Just a random line, a theoretical line tangent to the point. Okay. So obviously, if we plug in any number after here, right? Oops. Any number after there, after the 0, the slopes would be positive, right? Because it's going up. Any number between here and here would be negative in the derivative. So the outputs of the derivative would be negative because all the derivative does is give you slopes of the tangent line. All these lines are tangent to those points. Okay, does that make sense?
Yes, Professor.
Okay, so you need to find the function that does that for you. Now, the derivative does all kinds of things, but that's one of the main things it does. So here is a and that one's basic algebra. Let's move on here. Find the slope of the tangent line to the graph of the function. Do you agree that this is a linear function?
Yes.
So that means that no matter what point we choose, it'll have the same rate, right? It's not going to be like this one that is increasing, decreasing, whatever, right? It's just a straight up line. The slope would be your it would be the same as a tangent line slope. So obviously for here, all you would do is put 4/5. Now, if you don't see that, Was it plus something? It's -7 plus 7. So right here, if I choose any point, right, and then draw a line right next to it, do you see that it's the same slope, right, as the original line?
Yes.
So the slope doesn't change for the entire function because it is a line compared to the cubic function. It changes everywhere. So conceptually, you would just take the 4/5. There's nothing to do. It doesn't matter what point you choose. They gave you a specific point, but it doesn't matter because all points on a line will have the same slope tangent to that point. Does that make sense? Any questions on 2? It's more of a conceptual thing. Yeah, for all linear, if you ask for the slope of the tangent line, that is the same as the slope of the line. Because it doesn't change.
So if we are doing it in the exams, do we have to like go over all the process or just put the answer and then explain why?
For this one, if you can explain yourself, you don't have. They didn't tell us to use a limit process. Um,
Yes.
so we can get away by explaining that and avoid it. But number 3, we're gonna have to do the limit process because they didn't say it's not a linear function,
Yeah.
and we haven't learned any other techniques yet. So let's go ahead and practice it on 3.
Oh,
Okay,
thank you.
number 4, they straight up tell you what to do. Okay, to see how 4 and 5 they're starting to require the limit process. 2 and 3 they don't really, but it is kind of hard to find it with just the function. So let's do limit process on this guy. Also, what do you guys think? Just thinking about it, right? What kind of slope or what kind of rate of change, right? That's the same as the slope of the tangent line. What type of slopes would this type of function have? There's no power. There's nothing, right? This one was straight up the slope, the 4/5. But here there's no x. What kind of graph is this? Do you remember?
I actually don't know.
Yeah, it's a horizontal line. Yeah, which means there's a slope of 0, which means the tangent line is also 0. So the derivative of any constant will always be 0. If you do the limit process, it's going to be 0 anyway. But let's do the limit process or something harder. Um, let's do 5. Use the limit process to find the derivative of x squared plus x minus 8. Okay, so this is the limit process. So f is the original function. We use this notation f prime to denote the derivative f of x. Or you can use d dx f of x to denote derivative of f of x. Either one is fine. We usually start off with the quote because it's easier, but this is the more proper one, and the better one. Once you start going deeper into engineering and math, you kind of want to stick to this. Quotes is fine, but when you have a more complex problem or with multiple variables, then you want to know what the derivative with respect to what variable are you doing the derivative to. Since we only have one independent, it doesn't matter. But if this was like an XYZ function or a 3D function or, higher dimensional problem, then you want to note. Yeah, each apostrophe means another derivative. But I prefer you write it this way eventually. Okay, so the limit process to find the derivative means you take the limit of the difference quotient. So you take the limit of f of x plus h minus f of x over h as h goes to 0. If you find that limit, you will find the derivative of f to do this. Okay. Now, if you're uncomfortable with the indifference quotient, it's been a while, then do piece by piece. If you're comfortable with the algebra, then this is no big deal. But let's go ahead and pretend you forgot what this is. So f of x plus h is the first piece we should find. This means, plug it in, right? You guys still with me up to this point?
Yes, Professor.
Okay, so this becomes, let's skip a little algebra. Let me know if you're curious. Actually, that doesn't, there is no like terms here, so that's it. That is it. Okay, so now negative f. So we're going to do the next piece, subtract f of x plus h by this. So need more space. This will be x squared plus 2xh plus h squared plus x plus h minus 8 minus the original. So we're just doing the difference quotient. I think you first did this in college algebra, most likely. Or you're supposed to, but I don't know if you did.
That's what I was saying. I mean, what I meant to say. Because I remember doing that in college algebra in my second semester.
Yeah, it's familiar.
Yeah, it is. Especially the formula.
That's good. So it's the same thing. The only difference is you do a limit at the end.
Yeah.
So these cancel, these cancel, these cancel. Yeah, that's why we're showing all the steps just in case you're rusty. So this is the top part right here. So now let's write the whole thing. The limit as h goes to 0 of f of x plus h minus f of x over h is equal to the limit h goes to 0 of 2xh plus h squared over h. Then you see how the h's will reduce, right? So this will become, let's go ahead and put it down here. The limit as h goes to 0 of 2x plus h. I skipped a small algebra step. You cool with this from here to here?
Yes, I guess.
Let me know. I can add another detail. So once you take the limit, you end up with 2x. So this is the derivative. This is the derivative function of f. So f prime of x is equal to 2x. Hold up. I think I missed something. Oh, I missed an h. Yeah, right here. So there should be one more h right there. There we go. Yeah, it should be 2x plus 1. Any questions on any of the steps? So what I recommend is first find the difference quotient. Do piece by piece if you're not comfortable. So I did this first, subtracted f, and then just put it all together. Divide by h, take the limit, you're good. So this would be 2x plus 1. So make sure you practice the limit process, okay? You do the same thing here, it's just a different function. The ones that are difficult are these type. Let's do one of those. That's a little lengthy. You guys cool on this page?
Yeah.
Okay. Find the derivative. Of f of x equal to x minus 8 using the limit process. Okay. So first step, right? Step 1, find f of x plus h. So that will be 5 over x plus h minus 8. That wasn't too bad. The right step is that.
So we have the value of x plus h instead of x, right?
Yeah, this means whenever you see something like this, whatever it's there replaces the x. It's an
Oh.
input. Step 2, find the difference. This will be annoying because we have fractions, but life sucks, right? Okay. How do you subtract fractions?
Do we take denominator?
Yeah, we need the same denominators, right?
Yeah.
They're both prime. Do you agree?
Like how?
Can I factor the bottom?
No,
So that means it is prime. Can I factor this one?
no,
So they're both prime.
Oh, I just forgot the word word prime means.
Well, it's okay. It's important now, right? So, for example, if you were to add these two fractions, the LCD is 2 times 3 because they are 2 and 3 is prime. So you don't have to do anything fancy. This one needs a 3. This one needs a 2. You would add 3 6 plus 2 6. That's what we would do, right?
Yes.
So this one needs an x minus 8. This one needs an x plus h minus 8.
Yes.
Same thing. It's just not pretty at all. But it's not any different. The LCD is x plus h minus 8 times x minus 8. Since both denominators are prime. We don't have to think too hard because they're prime. This one needs x plus h minus 8. Here we go. Okay, I'm not going to multiply the bottom part, at least not yet. So I'm going to leave it as 5. Well, let's go ahead and show everything. Do you see that they have the same denominator now, right?
Yes.
So now you can subtract them. So on top, we're going to have 5x minus, well,
40, I guess.
yeah, that's fine. We'll do it. Minus 5 times x plus h minus 8. I'm going to write LCD because I'm lazy.
Are we not multiplying the 5 with the x plus h minus 8?
We will.
Okay.
I just want to put it this way so you can see that this minus is going to be on everything. This will be minus 5x minus 5h plus 40. Okay. All right. So it appears that these cancel, right?
Yes.
All right, so step 3. Go ahead and write everything. So that will be the limit if h goes to 0 of, the only thing left over is negative 5h over this h. Oh, I don't know, this is this algebra confusing you if I put the h like this? Right, if you divide by h, it would end up at the bottom.
Yes.
Is that cool with everyone?
And yeah, you're done. Yeah, I was just saying the top one.
Yeah, like if I divide this guy by h, it would be right at the bottom.
Yes.
It's the same as doing 1 over h times this. So these are gone. So now let's go ahead and write everything. So the limit as h goes to 0 of negative 5 over x plus h minus 8 times x minus 8 is equal to negative 5 over x minus 8 times x minus 8. So this is the derivative. This guy.
So at the top from the step 3, where you write the negative 5h, do we not write the original formula next the negative 5h, which is the x minus 8, I guess, for f of x?
F of x plus h minus f of x?
Yeah, I mean, you didn't write the negative f of x after negative 5h.
Well, they all cancel, remember when you subtract them?
Okay.
So the only thing,
Okay.
this right here, this whole thing is f of x plus h minus f of x.
Okay.
This right here, right? So we said way up here, this is this.
Okay, got it.
So now divide this by h, that got me to here.
Okay.
I brought everything back to what I'm supposed to. I just didn't want to write this over and over again.
Okay.
I wrote it back because we need to take the limit. H goes to 0, leaving me with 2 of these, which is a
Yes.
square.
Okay, thank you.
Does anyone have any questions on the algebra? Because I know rational functions can be annoying. So let me know if you forgot or if you're struggling with the fraction step. All right.
Hey, Professor, just real quick, I'm sorry. So on
Uh-huh.
that step 3, find the limit for h to 0.
Mm-hmm.
That first part right there, f
Here.
x plus, just write yeah, that one. So
Mhm.
is that something we're plugging in, or
This
is
entire
that
part.
a formula that we're supposed to be looking for?
This the top part or the entire thing?
Yeah, the entire thing.
This right here is the definition of the derivative as a limit.
So that's kind of like the formula we're gonna be using to continue.
Yeah,
with-
pretty much. I guess you can think of it that way. This finds f prime for you.
Okay.
So that's what we said on the last question, remember? We said that the derivative, or ddx of f, is equal to the limit of this difference quotient.
Okay. Yeah, that's what I was looking for. All right. Thank you.
Yeah. Yeah, it's pretty much kind of like a formula. So this is f prime right here. I just ran out of space. Any other questions before I move on? Okay.
Is that going to be a common thing to be using instead of like the chain rule?
That'll be so the first section makes you do it this way, and then after that you can use whatever you want. So the easy way is 3.2, 3.3, using power rule, chain rule, all that stuff. But the beginning, they want us to do it this way at least once. On your exam, you'll have to do this one time.
Okay. Thanks.
Number 8. So here they want us to find the equation of the tangent line of the graph of f at the given point. So basically we find the derivative, we plug in this x, that will give us the slope. Once you have the slope, you can find the equation of the line, right? You guys remember how to find lines from like, I think middle school, you first did that a long time ago. Given a point and a slope. Is that familiar?
Kinda.
Kind of. Given this function and a point, part A says find the equation of the tangent line. So again, let's graph this and go over what does tangent line mean again, just in case you don't remember. Okay, so basically you have an equation, you have a function, square root of x minus 3, and there's a point that they gave us as on the graph. They want to know what is the equation of the line that is tangent to that point. That's the question. What is the equation that makes this line? Do you understand what they're asking?
Square root of x minus 3. The equation.
The equation of the blue line that I just drew. That's what they're asking. Find the equation of this line.
Okay.
Okay. The tangent line to the point on the square root graph. So in order to do so, you need a slope and you need a point. We have a point, so that one's easy. The slope of a tangent line, we said, is the derivative at this x value. Okay, so let's write that down real quick. But that's the question. Like, is the question clear? Find the equation of this line. What equation makes this graph? That's it. Not complicated. That's all they're saying. Give me that equation. So in order to find it, let me make sure I wrote the question right. Of f at 19.4. So the equation of a line, the easiest one to use, or you could use this guy, mx plus b. The only difference is, let me write that prettier, is the m is a tangent slope. Just the slope of the line tangent. So you can use this to solve it if you want. But to find m tangent, you need the derivative. Only way to get that is with the derivative. Or you can use this guy. I think this one's better for this type of question. Because you just plug in the point, plug in the slope, and you're pretty much done. So step one, use find the derivative of f of x. We got to do the limit stuff. So the limit of f of x plus h minus f of x over h is equal to the limit of the square root of x plus h minus 3 minus square root of x minus 3 over h. This time I did everything at once. You guys still with me? Yeah. So this is f prime, the derivative. So how would you, we currently cannot plug in h. How would you deal with this? Now we're going back to chapter 2. How would you take this limit?
Maybe get rid of the square root.
Yeah, how do we get rid of them? We got to get, we do, that's a good idea. We got to do the conjugate now, right? Do you remember? Multiply by conjugate on top and bottom. multiplied by the conjugate of the square root part. Okay. So the top part will be a difference of squares, right? This will simply be a squared minus b squared. I'm not going to do anything on the bottom. We'll leave it as is for now. So when you square them, you end up with the limit as h goes to 0 of x plus h minus 3 minus x minus 3 over this garbage. So it appears that the h's will cancel, right? That's usually the goal when you're doing the limit process. You want the h's to cancel out. So x minus x, negative 3 plus 3, you end up with h over h. So these cancel. Now, if you take the limit, we'll do that in the next step. So we got a 1 left over square root of x plus h minus 3 plus square root x minus 3. Limit will be
Instead of h, we put 0, right? To
yeah, once you
find
take the limit, you allow h to go to 0.
Oh.
So the derivative f prime is equal to 1 over 2 square root x minus 3, right?
Yep.
Okay. Now that we have the derivative function, we can do step 2. You guys cool with the limit process on all these steps before we move on to step 2?
Yep.
Yeah, let me know if something's weird or if I make no sense. Just tell me. Step 2, use the derivative f prime to find m tangent. So m tangent is equal to the derivative at that point, 19. So that'll be the derivative, oh, sorry. That'll be 1 over 2 times the square root of 19 plus, oh, sorry, 19 minus 3, right? That's what it was. Square root of 16 will be 4, so this will be 1 over 8, correct?
Is it 16 in this? Is it
Yeah,
16?
this is supposed to be 16. You write it better.
So the square root of 16, isn't it 4?
Yes,
And we multiply that by 2 and it's 8, right?
yes.
Okay.
So step 2, you use the derivative to find the slope of the tangent line. That's what derivative can, that's one of the applications of derivatives. Step 3, I'm gonna recommend this one. To find your equation. Plug in m tangent, which is 1/8, and the points 19 comma 4. So this is my x1, y1. So you get y minus 4 equal to 1/8 times x minus 19. So we're pretty much done. This is the equation of the line, but they want us to solve for y. So solve for y.
Subtract plus 4.
Yeah, then distribute. Add the 4 minus 19/8. Where that is. That will be y equal to 1/8 x 8 over 8 times 4, 32. That's 32 minus 19.
I think so. Mm,
13.
mm.
Yeah, yes.
Okay. Thanks. All right. So this is what they want for part A.
Can you please just briefly explain how did we get plus 13 or 1 over 8 x?
Oh, I'm
from
sorry.
the buffer?
13 over 8. We gotta add 4, subtract, do 4 minus 19 over 8, so you'll get 13/8. You gotta do the fraction.
Oh,
LCD will be 32 over 8 minus 19 over 8.
okay.
It should be 13, right?
Okay, got it. Thank you.
So that's what they want here. That last equation we got.
Would we have that type of questions in the exam?
Yes.
Is it 2 or 3 or just only 1?
I'm sorry.
Would it be like two of them, 3 of them, or only 1?
I don't know. Not
Okay.
sure.
It was a long one.
Yeah, I know. But there's faster ways to find the derivative. So for that kind of question, we'll use a different method.
Okay.
All right. So there's the equation. So the point tangent to that line is this one, to right next to it. That's what we found. Which goes here. So it should be, I don't know. D maybe? Yeah. Any questions on 8? All right, for the next question, I'm just going to go ahead and skip the derivative step so we can solve the problem. Because derivative takes a while. Right. Number 9. Find an equation of the line that is tangent to the graph of f and parallel to the given line. So they gave us this function. They gave us a random line. If you solve for y, you will see that this is equal to 6x plus 9. If you find the derivative, you will get 2x. Okay. So they want us to find the tangent line of the graph of f parallel to the given line. So what does it mean to be, what is the requirement for two lines to be parallel? Yeah, they need the same slope. So we're going to use that fact to figure out what the x value should be in order to get this slope. I mean, you can kind of already see it, right? What does x have to be to get a 6? Yeah, so what we're supposed to do, we're gonna show it, but you set the derivative equal to the slope you want and solve for x. So this slope is 6, and M10 must also be 6 so they can be parallel. All right, so we get, yeah. And the x value to make this happen will be 3. If x is 3, what will the function be, or the y value? Right, the original gives you points, right? The derivative gives you slopes. That's a square.
So do we put 6 in the first function f of x equals x squared?
No, we use this one. It gives me a 9. So f of 3 is equal to 3 squared, which gives me 9. So now the point 3 comma 9 is the point that, how should I phrase that? The point 3 comma 9 is where the tangent line has a slope of 6. So let's visualize this because it's kind of weird, right? They're giving us it's the same stuff, but they're asking it in a strange way. So f is equal to x squared. The rando line is y equal to 6x plus 9. The point in question, I had to find it myself. It was not given to us. It's 3 comma 9. I want a line. Yeah, pretty much. That is parallel to the blue one and tangent to here. So since I found that point, it is parallel to the line in question because I found that point with the assumption the slope was 6. Remember on the paper?
Yes.
And that's what we're kind of like, we're using clues to figure out what the tangent line will be. Does that make sense?
Yep.
So we knew it had to be 6. So I set it equal to the derivative. And then I said, okay, well, if the slope is 6 with the tangent line, the location for that would be x equal to 3. To find the y value, I got to use the original function because this gives me derivatives. Or this one, sorry. So I plugged it in there to get y, or f of x. Once I have that point, I can find the equation of the tangent line because I have a slope and a point. So y minus y1 equal to m tangent times x minus x1 will be y minus 9 equal to 6 times x minus 3. Are there any questions on how we found this strange line here?
I just have a question about the slope. How did we find the slope of 6?
So the hint that they gave us is the tangent line has to be parallel to this given line.
Okay.
So the given line has a slope of 6.
Okay.
So the tangent line must also have a slope of 6.
Got it.
So this allowed me to set it equal to the derivative and find x.
Okay.
Use that to find y. Once you have a point in the slope, you can use this formula.
Okay.
Any other questions? All right. Give me a second here. Let me check the last couple of questions before we move on. Let's take a 5-minute break. I need to find a definition. record before I forget. I'll leave these questions to you. This one, whatever, I guess. Okay. So in order for a function to be differentiable somewhere, it needs to be continuous there. This function is continuous everywhere except the asymptotes. And remember, we talked about what it means to be continuous. You guys remember the requirement? We said the limit has to exist at that location, right? Does the limit exist here? Or here?
No.
That's hence the limit or the differentiable location is everywhere except here and here. That's why they wrote the interval like this. This is saying the x values where the function is differentiable is negative infinity all the way to -3, but not including -3. Everything between -3 and 3, but not including those endpoints, -3 and 3. Everything after 3 is cool, but not 3. Does that make sense?
Yeah.
Any questions on 12?
Is that 12 or 13?
12, because I deleted a question, so it hasn't updated on your end.
Okay, got it.
If you hit refresh, it should change.
Okay.
This one, the domain is -1 all the way till infinity, right? We cannot go below -1 because then we'd have a negative inside the root. So where are we differentiable? In other words, where can we take derivatives? In other words, where are we continuous on F? Do you see any points of discontinuity on this graph here? There's no holes, right? No asymptotes. There is no issues with this graph. So it's continuous everywhere on this graph, which means we're differentiable everywhere. Does that make sense? All right, let's move on to the next section. Let me take a look at it. It's pretty much it for 9.1. 9.1's a little annoying, and I'm sorry. So 3.2 is a lot more chill. Differential means you can take a derivative at that point. In order for it to be differentiable, it needs to be continuous there. So all you got to do is check. Where are we not continuous? If you find a point where it's not, that means you cannot take derivatives there.
So if that number was something other than just x plus 1, it's still going to be everywhere.
Yeah, because there was no gaps, right? Or weird any weirdness. Like the limit existed everywhere for any point on the domain. So we're good. Okay. So here's when we start doing the easy rule for power rule. And they have you find the slope. The 3.2 is basic differential rules and rates of change. This shouldn't take too long, but we technically still have 20 minutes. Basic differentiation. Rules. And rates of change. All right. Let's go over the power rule. If f of x is equal to x to the n, where n is an element of the real numbers, then f prime, the derivative, is equal to n times x to the n minus 1. Number 2, constant rule. If f of x is equal to c, where c is an element of the real numbers, in other words, a constant, then the derivative of a constant is equal to 0 for any number. So the derivative is the slope of the tangent line, and it's also the rate of change of a function at a certain point. So the rate of change of a constant is 0 because it's not changing, hence the word constant, right? The trig derivatives, let me go ahead and give them to you. If f of x is equal to sine x, then the derivative is equal to cosine x. If your derivative is equal to cosine, then the derivative is equal to negative sine. If your function is equal to tangent, then the derivative is equal to secant squared. If your function's equal to secant, then your derivative is equal to secant x tangent x. If your function is cosecant, the derivative will equal negative cosecant x cotangent x. Yeah, secant squared. If f is equal to cotangent, the derivative is negative cosecant squared x. All right. The exponential derivative if y is equal to e to the x, then I should stay consistent. F of x, then f prime of x is equal to the same thing. E to the x is the only one that doesn't change when you do a derivative. Although, if there's a number up there, let's call it k, then the derivative would be k times e to the kx. And that's because of the chain rule, but we'll get into that way later, in a few sections. All right, that's all we need to do this section. All right, let's skip those. Here you would take the derivative and then plug in 1. Let's do 2, I guess. Given y equal to x to the negative 1/3 find the slope of the tangent line. Let me switch over. So remember we said that forgot 1, 1. So what you gotta do, m tangent for this case is equal to the derivative at the x value they're talking about. So first find the derivative. That would be equal to negative 1/3 times x over to the negative 1/3 minus 1, right? The rule says you bring the power down, subtract 1. So that will be negative.
So if you
Oh,
bring the, I'm sorry. So if you bring the power down, why do we write it again?
the rule says you bring it down and then subtract 1 from the original.
Oh, okay.
So negative 1/3 minus 1 negative 4/3, right?
Yes.
So we have the derivative, much easier than the limit process, right?
Yeah, definitely.
So now just plug in the 1. That'll be -1/3. That's the slope of the tangent line. This is m tangent. So the same thing we did last section, but using the new rule, the power rule. Any questions on number 2?
Man, it's just so much easier using this chain rule instead.
Yeah, it is. That's the main way you're going to be doing it throughout the entire chapter. It's just you got to do the limit process one time on the exam. That's it. Okay. Number 3. Find y prime given y equal to -13. What is the derivative of y equal to -13? What is the derivative of any constant?
Zero.
Yeah. You can prove it by doing the limit process, but I'm not going to do that. Let's do 5. You guys cool on 2 and 3. How would you deal with 4th root of x? How would you take a derivative? The power rule is the easiest way, but you have to set it up first. Or you could do a limit process. But if you remember your algebra, you agree that this is the same as this, right?
Yes.
So that means the derivative would be 1/4 minus 1 is a -3/4, right?
Yes.
Now bring that power to the bottom. That would be 1/4x to the 3/4. That is the derivative. If y is equal to -6x squared plus 5x minus 8. Oh, to convert the square root, remember that the nth root of x for any root is equal to x to the 1/n.
Yes.
Is one of the many rules of exponents. So what is the derivative of this guy? Right, so there's a property that says you can do term by term. So piece by piece. Bring down the 2, subtract 1, plus 5, bring down the 1, subtract 1, minus 0. So the derivative of the first term, derivative of the second term, derivative of the last term. So this will be whenever you take a derivative of a linear function, you're always left with just the slope. You don't have to show this step here, but I wanted to show you why it is 5. Derivative of constant, 0. Gone. Derivative of this guy is a power rule. Well, they technically both were, but is there any questions on 6?
Sorry about that. I didn't mean to interrupt. Why'd you put the x's 0?
Yeah, because it originally has a power of 1, right? The linear.
Yes.
Oh yeah. Sorry.
So you bring
So
the
you're
1 down.
subtracting that and making it 0.
Yeah, you see it? 1 minus 1.
Yeah, but we could just leave it as 12x plus 5, right? Or negative 12x plus 5.
Yeah, you don't have to show this. But I want you to see why it is just 5.
Is that negative 12x plus 5, or is it just
Yeah,
12x plus 5?
negative 12x, right? Because you brought down this 2. 2 minus 1. Now it's a single 1 power. Negative 6 times 2. And we're done.
Thank you.
What's the derivative of cosine in the notes? Yeah, negative sine. So negative sine times pi over 3 gives you this piece. Derivative of sine is cosine, so there we go. That's it. So y equal to pi thirds cosine minus sine. Derivative would be, derivative of cosine is negative sine. Derivative of sine is cosine. So we end up with negative pi over 3 sine minus cosine. That makes sense?
Yes.
All right, one last question and we'll call it a night. Y equal to 4/7 e to the x plus, I think this is 9. Yeah, whatever. So the derivative e to the x we said is itself, right? Doesn't change. Derivative of cosine we just said was So that's it. But using the rules, it's a lot easier to find derivatives, right? Way better. You guys have any questions on 3.1 or 3.2? All right, guys. Well, we'll stop here. Let me know if you have any issues, if you want to